Okay, so today we are in part 2 of section 8.2. All right, in part 1, just as a quick recap, we checked solutions. Everybody remember how to check solutions? Okay, so we have an ordered pair. The first number is X or Y. The first number is X, the second number is Y. You substitute it into the equation. Once you simplify, if both sides equal, then yes, it's a solution. If they don't, then it's not a solution. We went over this in part 1, so if you need a more detailed breakdown, you can rewatch part 1 of 8.2. Then we set up tables. Why did we set up these tables?
Oh, I know. So you can see the changes in each.
Okay, if I can find my tables. Give me a quick sec. All right, here they are. Okay, graphing a linear equation. So in order to graph an equation, what do I have to have? Ordered pairs, right? I don't know what to graph. I don't know where my points go. So I have to have ordered pairs. Well, we talked about the fact that there's like an infinite number of numbers you could choose to be in your domain. However, that would make it really difficult to grade, and you don't want to have numbers so big that they don't fit on a normal size graph. You have to make your graph humongous. So what is my standard domain set? I asked you to write it in your notes on Friday.
-2, -1, 0, 1.
Very good. My standard domain set is -2, -1, 0, 1, and 2. Then I also had another kind of domain set. And this domain set needed to be used whenever there was a fraction connected to x, like we see here in the third equation. And how would I come up with my domain for a custom set? How would I come up with it? What number will tell me what numbers I have to choose? What number, Amy? The denominator. The denominator tells me, okay, I need to use multiples of 3. If my denominator was a 5, I would use multiples of 5. Okay, so whatever my denominator is. And again, I have to have negatives and positives together. So that's how I came up with my 2 domain sets. Wait now, how did I come up with all these y values? Where did those come from? Where did all my y values come from? I plugged in my x values, right? So -2, I plug in for x. What's 2 times -2? -4 minus 1 is -5. So that's where I got that from. Okay, and then so on. I just keep doing it. Once you get to that third number, that's the second number. Once I get to the third number, if you can find a pattern, go ahead and just fill in the other 2 numbers. If you can't, just keep substituting. And now what we're going to do today is we're going to graph these 2, the outer 2, this one and this one. We're going to graph these 2 equations. So I need you to get out a piece of graph paper so we can start setting up our graphs. Please fold your paper in half, then fold your paper in half again the other way. If you have that clear protector on there, I suggest that you, on your homework, not on your notes per se, but on your homework, use the back side so you don't have to worry about the clear part that protects the holes.
Oh, okay.
Yeah, like that clear strip. It's like a piece of tape or something, but it keeps the holes from ripping. Yeah, use the back side so you don't have to write over that. You're going to fold it in half one way and then fold it in half the other way. So you're going to make 4 sections out of 1 sheet of graph paper. Okay, so let's set up these graphs. All right, remember when you're setting up your graphs that you skip, guys, please pay attention to this, okay? Skip that first block on each side of the graph. Okay, skip that first block because that's your 1. That's your 1. So skip the first one, 2. Skip it, 4. Skip it, 6. Skip it, 8. Okay, so go ahead and literally you're copying what's up on the screen. Okay, so imagine that this is one section of your graph paper. So you could potentially get 4 graphs on one side of the graph paper. You're just doing it in like maybe that top left section of your graph paper. So the very first point is -2, -5. Did you plot a point there? Okay. All right, so here's what we're going to do. Okay. I need you to go to your first table on your notes. Okay. And now we're going to follow the ordered pairs. Now that we have all our graphs set up, we're going to follow the ordered pairs and we're going to graph these ordered pairs on the graph. So the very first point was at -2, -5. What's our next point? -1, -3.
Wait, so this side's supposed to be the X?
Yes.
Well, I had it Y X.
No, it's X and then Y. That's why we have each axis labeled. And then what's our next point? 0, -1. Then what? 1, 1. Then what? 2, 3. And then you draw a straight line through all the points. And that is going to form a straight line because remember guys, we're graphing linear equations. It has to form a straight line. So if you have a point, let's say, you know, we didn't have our line. If you have a point like over here, kind of going haywire, and you try to draw your straight line, and then it, oh, I didn't mean to do that. You try to draw your straight line going through, and oh, it looks great. Oh, and then it goes way over here. Okay? Which one is wrong? I mean, obviously this one's wrong. It doesn't fall in line. No pun intended. Okay? All right. Yeah, you like that, huh? Okay, so. All right, so our straight line, if I can get it redrawn, needs to go straight through the points. All right, and then you need to label the equation, and that's just kind of matching up the line with the equation. So now I want you to do the third equation from those tables, the one that was 1/3 x. Okay, I want you to do that one on the second graph. Go ahead and plot those points. Remember to skip the first block on each side. All right, go ahead and plot those points on your graph. It should form a straight line. Okay, so now I plot -6, -1, -3, 0, 0, 1, 3, 2, 6, 3. And it's still a line. It's just a different looking line. All right, and then I need to plot the equation. What was it? Y equals 1/3 x. What was the last number? +1. That's what I thought it was. +1. Okay, so we're just labeling the equation. Any questions on this? You have two just like this, where they give you the equation. You have to come up with your ordered pairs and graph. Any questions? Okay, now we need to talk about vertical and horizontal lines. Okay, so on the third graph, I'm going to let you graph both of them on the same line. Or on the same graph, I mean. Okay, so sometimes it will only give you y equals 3 or x equals -2. It literally doesn't give you anything else. And you have to graph that line. Well, what always threw me off in school was like, how in the world do I just graph like one number? Okay, and here's how I do it. Whatever it tells me y is, that's where I plot my point. Y equals 3. So on your third graph, plot a point on a y value of 3. All right, and here's what it's saying. No matter what the x value is, -2, -4, -6, 2, 4, 6, 8, it could be on all of them. No matter what the x value is, the y value is going to be 3. So by drawing a horizontal line through that point, you're saying, okay, the x values might change, but the y value is never going to change. It's always going to be a y value of 3. See that? All right, so did you draw your line? So what do you think is going to happen on x value of -2? Plot the point on -2. And now, again, no matter what the y value is, it could be as high up as it can possibly go or as low down as it can possibly go on y, but the x value will always be -2. It's a vertical line. Okay? So you might have one of those random questions on a homework quiz test where it just says graph it. Well, basically, the only way to do that, okay, is just to plot it on that point and then draw the line. All right? Good? Okay. So that's horizontal and vertical lines. And now the last thing that we need to learn is what we know to be function form. Function form, this is my standard formula, and you need to write it down. Y equals mx plus b. We're going to learn what some of these other variables mean tomorrow, but here's what I need you to know for today. Okay? That the y value means that on one side, you need to solve for y. Okay? You have to isolate your y value on the left side of the equation by itself. So we're basically in example 5 going to start rearranging these equations so y is by itself on the left side. Then the other thing I need you to know is that your x term always comes first on the right side. This is going to look kind of goofy. Sometimes it's going to mean that the negative number comes first and then the positive number comes second, and you're like, you know, why can't I just write it the other way? Well, because it's not function form. That's going to make more sense in just a second. All right, but you need to know this formula right here, y equals mx plus b. And now let's read the statement up here. A linear equation is always a function unless what? It forms a vertical line, because guess what? If it's a vertical line, it doesn't pass the vertical line test. Remember that vertical line test that we did? If it is a vertical line, it's going to fail that miserably. Obviously, it would hit it on like every single point, right? So, a linear equation is always a function unless it forms a vertical line. So an x value of 4 graphed as a vertical line, no, that's not a function. All right, you need to know that. That looks like a good true-false statement, or even short answer. Okay, unless it forms a vertical line. Any questions? All right, so here's what it looks like. Example 5. All right, in example 5, we have 2 steps. Step 1 is to take the equation and to write it in function form. What was function form? Read it back to me. Y equals mx plus b. Okay, well on this one, is y by itself on one side of the equation? No, so I need to get there. I need to do that. Here's what I need you to understand. This is a term, this is a term, this is a term. The first thing I'm going to do is I'm just going to move them right and left. We do that by opposite operations. X is positive, so I need to subtract x to the other side. And I need to rewrite my equation. So for some of you who have been fighting me all year on showing your work, this is really where it's going to pay off for you if you've been showing your work, and where you would struggle if you're still struggling with showing those steps. Because now you need to rewrite it. 2y equals, and what did I say comes first? The x or the number? The x. Always comes before the number. So even though the x is negative, and it seems more natural to say 6 minus x, I actually have to say negative x plus 6. Wait, where did that 1 come from? I didn't see a 1 up there. In front of every variable that doesn't have a number, we always have an understood 1. I put it in there to remind you of that. And you might want to write it in there to remind yourself of that rule. Okay, it's very important. So now I'm still not done because y is still not by itself. What do I do? Not subtract it. How do I get y by itself? Divide by 2, right? This is multiplication, guys. I divide by 2. Divide by 2, and here's my rule. Divide every term in the equation by that number. And now y equals negative 1/2 x plus what's 6 divided by 2? 3. Function form. Y equals mx plus b. Y is by itself. The x term comes before the number. I'm good to go. Now, I know this is brand new to you. I know that you've never learned it before. If you're in honors, you've never learned it before, and if you're in standard pre-algebra, I don't think we learned that in 7th grade math either. I could be wrong. We might have touched on it, but this is a pretty new concept. Is it okay if you don't understand it the first time?
Yes.
Yeah, absolutely. Is it okay if you don't understand it the second time? Yeah, still okay. Third time? Yeah. All right. Sometimes we need, on average, of 5 to 7 exposures of a new concept before we can master it. That's why I have the YouTube videos. That's why we review in class. That's why we do homework assignments. All right. But I still want you to practice this second one. Don't sit there with a blank look on your face. I need you guys practicing. All right. So I'm going to go ahead and pause the recording. We're going to work through this, and then we'll start it back up. All right. So what would I do first? Very good. Now, typically, here's a really common answer I get. Oh, I need to divide by 2, right? Oh, okay, well, I see 2x. Well, I need to divide by 2. Well, here's the problem. If you divide by 2, what is still over on that side? An x? No, an x is still left, right? So dividing by 2 isn't the answer, and dividing by 2x isn't the answer either. If I need to move it to the other side, I need to subtract it. Subtract 2x from each side. Okay, now what am I left with on the left side?
3y.
Negative 3y equals what term comes first, the 3 or the negative 2x? Very good. The x term comes first. Is it plus or minus 3? Plus 3, because 3 is positive. Otherwise, it'd have a negative sign in front of it. Now, what do I need to do to solve for y? Divide everything by negative 3. Okay? Is it a little clearer this time than it was last time? Okay. It should start to get clear, more and more clear, okay, the more we do. So now y equals 2/3. Wait, why is it positive?
Because the
Negatives cancel. 2 negatives is a positive answer. Okay, so we're learning something. That's a great sign. 2/3 x minus 1. And now it's in function form. And so now that it's in function form, I'm back to example 3, where I take the equation and I make a table so I can graph it. So go ahead and make your input-output tables for both of these equations. So you've got it in function form. Now you need your input-output tables. Are you going to use a standard domain set or custom? You have to figure it out. I won't say it out loud yet. And then the easiest part at that point is just to get them over on our graphs. Okay? You have 2 problems like this on your homework. The reason I only gave you 2 is because they're 3-step, and these 3 steps are going to take you a few minutes. Okay? So 6 problems total on your homework tonight is not terrible. In a normal scenario, I would never give you only 6 problems, but because these are very long problems to solve, that's why there's only 6. Okay, fair enough? All right, so I need tables. Go ahead and set these up. We're not quite done. All right, we need to set up tables for each of these equations. Okay, go ahead and finish filling them out. Give me the domain set for the first one. What's going to be my domain set? What is it?
4, -2, 0, 2.
Very good. And then how do I come up with my y values?
Multiply -4 times 2.
1 negative 1/2 times negative 4 plus 3 is 5. Negative 1/2 times negative 2 plus 3 is 4. I'm just plugging these numbers. Whoops. I'm just plugging these numbers in for x. Each one of them. 3 and 2 and 1. What about my my domain set for the second one? What's that going to be? What is it? What tells me what numbers? The denominator, it's a 3, so I'm going -63036, and then my output. And now you can graph, okay? So I know it's a lot for one problem. This problem is, 3 steps. You have to write it in function form, then you have to do your table, then you have to graph. So like I said, 2 of those, and if you understand that, that's everything you need to know for 8.2.